in today's discussion, I have mentioned when I discussed the problem based on matching, borax bead test and microcosmic salt test. These are usually done for colored salts. So this point I have already told you, you should remember. Now based on this, question number 7 is framed. Borax bead test is answered by which of the ions? So whenever borax bead test or microcosmic salt test it is mentioned, immediately you should remember these tests are meant for the identification of colored salts. Now look at the 4 answers. A, CO2 plus, B, Cu2 plus, C, Zn2 plus, and D, Ni2 plus. Probably you remember colored salts are usually those of copper cupric salts, nickel salts, cobalt 2 salts. All of them are usually colored. Zn2 plus, for example, zinc carbonate, zinc sulfate, zinc salts are colorless salts. And based on the principles of borax bead test, we can come to the conclusion that borax bead test is answered by colored salts, namely A, B, D. These 3 form colored salts, whereas zinc salts are colorless. And so for question number 7, more than one answer type, A, B and D, these are correct answers because these 3 form colored salts, and these colored salts will be answered by this borax bead test. All right. In the basic radical analysis, group 2, you pass hydrogen sulfide through the salt solution in presence of dilute hydrochloric acid. Now usually in group 2 analysis, we have 2A ions and 2B ions. In the basic radical group 2 analysis, we have several metallic ions, mercuric salts, cupric salts, cadmium, arsenic, antimony, bismuth, tin, and so on. Of these various ions, copper, cadmium, mercury, lead, etc., these are all present in group 2A. Arsenic, tin, etc., these form group 2B. For separating 2A and 2B basic radical ions, we use a reagent which is yellow ammonium sulfide. Now addition of yellow ammonium sulfide is based on the solubility of the sulfides. So yellow ammonium sulfide solution is a suitable reagent for the separation of group 2A and 2B. Now let us consider the various possibilities. 4 pairs of sulfides are given, HGS and PBS. Please remember, Hg and Pb form 2A, both of them are 2A. C, lead and bismuth, again 2A. Copper and bismuth, 2A. But B, consider CdS and arsenic sulfide. Cadmium comes under 2A and arsenic comes under 2B in the answer B. But whereas in A, C and D, these three pairs are sulfides of 2A. Both of them are sulfides of 2A, A, C and D. Therefore, the correct answer is B, wherein cadmium sulfide comes under 2A and arsenic sulfide comes under 2B, for which we make use of ammonium sulfide solution for the separation of cadmium and arsenic into 2A and 2B sulfide. So, B is the correct answer. Come to 9. 9. Now, this question is based on the fact that even though we consider several salts containing the same acid radical, consider A, B, C, D, all of them, the four answers are nitrates. You should remember one point, even though all of them are nitrates, they will not give the same reaction. Here, action of heat is tried. These four nitrates are heated separately. The question is, in which case NO2 is not evolved? NO2 is a brown gas, you know. By heating which salt NO2 is not evolved. Now, for this you should know the reactions of this. Silver nitrate, in the previous problem we have worked, we have seen silver nitrate on heating gives Ag, NO2 and oxygen. So, action of heat on AgNO3 will liberate NO2. So, A is not the correct answer. All right, come to B, sodium nitrate. Now, sodium nitrate on heating gives only two products. One is NaNO2 and another is oxygen. So, even though it is also a nitrate, on heating this does not give NO2. So, B is correct answer. C, lead nitrate. Now, you remember one term, please remember this. In qualitative analysis, in some books it is given decrepitation. Decrepitation, whenever you find a word like this, immediately the mainly two salts should come into your mind. One is lead nitrate, another is barium nitrate, even sodium chloride. Decrepitation means a crackling noise. If you heat, for example, lead nitrate crystals, you will hear a crackling noise, and at the same time there will be evolution of a brown gas, NO2. So, action of heat on lead nitrate will give NO2. So, C is not the correct answer. Come to D, ammonium nitrate. Ammonium nitrate action of heat, it is a method of preparing one of the oxides of nitrogen, namely N2O. When ammonium nitrate is heated, NO2 is not formed, but N2O is the product. So, for 9, more than one answer correct, namely B and D. And with this, let us try to conclude. In the second group of analysis, in qualitative analysis, in presence of dilute hydrochloric acid, we pass hydrogen sulfide. Now, what actually happens here? Of course, you should not say sulfides are precipitated, but what is the principle behind it? We assume that this ionization takes place. Ionization can take place to a small extent or to a greater extent, but here this ionization of course takes place. When you add HCl, it also ionizes, but you can notice on ionization H2S gives H plus, HCl also gives H plus, and this H plus from HCl reacts with this, and so this backward reaction will take place. Instead of dissociation or ionization of H2S taking place, it is the suppression of the dissociation of H2S that takes place. So you should remember this point. We pass H2S in second group and fourth group, but in second group this dissociation of H2S is suppressed by the addition of HCl, because of which only the second group sulfides are precipitated and not other sulfides. So the reason is the addition of HCl is to suppress the dissociation of H2S. Do you follow?